Okay, lecture E2 clay bricks. It's obviously about clay bricks. And I need to get my system working by having this running. Right. Introduction, properties of clay bricks, production of clay bricks, application of clay bricks, and design consideration, as we always do this in this lecture. It's one of the oldest materials mankind is using. It's cheap, natural, durable, and it's simple to work with, which makes it a very, a very appreciated material for our mankind. It's a uniform size of square blocks manufactured out of clay, being fired, and by that being stable against environmental impacts, and can be manufactured in a simple way, which means unskilled labor can build to a certain extent to certain geometry objects. The properties, as we always discuss it in this sections, durability, density, compressive strength, tensile strength, limited tensile strength. It's a fracture behavior. It's a brittle material. It breaks brittle. It has good fire resistance. It makes it an interesting material for buildings because, well, by that we do have less difficulty with fire. When we come to certain numbers, compressive strength of a certain variety, tensile strength, as said, very limited, thermal conductivity quite high. So it transports energy very well, which leads to the situation that we create different shapes of bricks, not only solid, but with a lot of openings inside, to reduce the mass, by that to reduce the energy transport capability of the material. We will see that later in a minute. In a minute. Design life, maybe also something which is interesting. It's set, it's up to 50 years. Now, yeah, we know brick buildings being a lot older than 50 years, so it's a very durable material which can last a very long time. The main ingredients to create clay bricks, it's mainly alumina and silica. Silica sand, the largest part, and some lime and some iron oxide to compact the material as material. Production of clay, we see that main global outline preparation of the raw material. We'll talk about it in a minute. Then the shaping, two ways, the extrusion and the mold, the drying process, the firing process, then after firing, cooling, obviously, packaging and transport, as it is designed here. The preparation of the raw material, it's digged in mines. This leads to the situation that you do not want to transport the material that far, with the consequence that the manufacturing is mainly done close to the mining, as I say, traditional setup. Current situation when transport is simpler, this may change, but the same principal setups, the mine is very close to the manufacturing plant of the material. Then the whole material is crunched and mixed, so brought to a certain shape to be possible to be either extruded, which is the one process, or brought into molds. The mold, it's actually in a brick wall with a mold which creates that square brick. Then the clay is brought inside, the whole thing dries a bit, then the brick is taken out and then brought into the firing process versus the extrusion process. The extrusion process picture which we show here is actually extruding an endless line of clay through a certain nozzle which creates the outer shape. And to create the inner shape as well, we see these molds, which are extrusion nozzles, which allow that the clay actually can, say, broad through the nozzle, and by that having these openings, like we see in the picture, to create a lighter brick. It's actually like extruding cookies with some inner openings being added to this. And you see the mold, the extrusion mold for the inner openings here. Why do we have these openings? As said before, thermal conductivity, material transports very well energy. So if you reduce the dimension of the mass of the material, you reduce also the thermal conductivity of the brick by itself, which is a way to make the material a bit better insulating as a general material. Then this whole thing goes into a drying process. That's a quite long lasting process, and then into a firing process that is brought to certain temperatures, either low temperature in the first step and then higher temperature in the the second step to change the clay into the brick nacelle, to crystallize the clay into a brick material as it is wanted. And then this whole thing needs to cool as another process. And after this cooling process, in some of these manufacturing processes, they even mill the surface to secure that this is really flush and that the tolerances are limited with this for the material. Then packaging and transport, which is obvious as system. We have this idea of creating solid bricks into more insulating material by adding more cavities, which we see on the left picture. And at a certain point, this cavities and making the brick lighter is getting to its limit. And to then still increase the thermal performance of a brick, we nowadays often also have in the cavities some insulation material, Rockwool in this setup, to make the brick in total lighter, to by that create a better thermal insulation properties. Typical brick sizes. This is a German picture. You can do the same for the Dutch or the Danish or the English or wherever. These dimension, which is something very local, and define the setup of the brick structure. So the grid of the brick structure and of the brick building, how it is built, is related very much to the dimensions of these systems, these dimensional systems for bricks. Design application, we can have bricks either as a load-bearing or as a cladding element. The load-bearing element means it's a solid brick wall, and then the solid brick wall, if it needs, is covered with a plaster, which is the left picture, or it's covered with an additional outer layer of ventilated facade, cold facade, as we named it in our system, which then allows us to maybe add also insulation as it is designed here. But we also can do this with an additional layer of clinker bricks, very well fired bricks at the outside, which then again act as a rain screen at the outer shell of this ventilated facade, as is already explained in other lectures already. Or we really simply go to a cladding setup, then the bricks itself are only brought in front of the structure, an inner layered structure, an inner insulation, a cavity facade, whatever, as a pure cladding device, and then are mainly made to appear as brick surface, so to say. New applications, this is a research project which we currently do in Darmstadt, which is 3D printing bricks, and you can imagine that these bricks in this very free form are complicated to be extruded, actually impossible to be extruded. So there's new considerations of how to make these bricks in a different way by this additive manufacturing process. Design considerations. When we add bricks as an outer layer to a ventilated facade, cavity facade, we need to somehow get the loads back to the main system. So there needs to be a fixation, a bracket system, which takes the load from the bricks to the main structure as a set. If we end up with expansion joints do appear in situations where we have one wall of outer layer of brick cladding and another wall of an outer, and they actually contact each other and they're exposed to sun in a different way, so that by thermal expansion, compressive forces are appearing within these systems. They need to be brought to a certain distance, and this distance needs to be sealed. And this sealing could be done either in a zigzag version or in a vertical version, which is obviously a lot simpler to handle as a set. And then this is sealed in an elastic way, which allows then the movement of the bricks in these systems, which brings us to sealant opportunities. It's at the right with a strip, which is more an aesthetical part, or the middle one with a silicon line, which allows this changes of dimension, which allows this compressive situations, or far right, the more common way of doing with a mortar-filled sealant for enclosing the joints of these brick systems. And by that I end this lecture. It's a typical setup. The team which designed this system.